To better help us graph hyperbolas with a little bit more accuracy, we know that hyperbolas approach several different lines asymptotically. So there's asymptotes involved with hyperbolas. And the asymptotes are located in, depending on which version we have. If we have the transverse axis along the x-axis, we have asymptotes at the line y equals b over a times x and y equals minus b times x. Similarly, if we have a hyperbola that's along the transverse axis of the y-axis, we have asymptotes at y equals a minus or a over b x and minus a over b x. So those are the lines that will help us kind of draw and help us kind of get a better sense of what the hyperbola looks like. And when we do that, if we just find those asymptotes and then find the vertices, and then the foci will help us a little bit, we can pretty much graph a decent looking hyperbola. Okay, so hyperbolas have asymptotes. We know where those asymptotes are at. They're described by two different lines in each series. From there, let's look at a couple of examples and see what we can do with them. So let's graph hyperbola based on some of the things that we know and maybe some of the things we can figure out along the way. So our first strategy in graphing this is let's just draw the coordinate axis. As I'm doing this, are you able to determine which axis is the transverse axis? And we determine that by looking for where the plus sign is at, that's located with the x squared. So then I know that my 25 is my a squared, and my 16 is my b squared. First thing I need to kind of recognize. So recognizing that now, I know that a equals 5, which tells me that I have a point on the graph at 5 and 0 and negative 5 and 0. That's helpful. The next part I want to do is I want to draw the in-between box. And the box was the square that helps me start to develop the asymptotes. So I know then that I have a box at plus or minus a. And that was at 5. So I have a side of a box there, and I have a side of a box here. The top side of the box is reflected by b, by the 16, or in this case, b equals 4. So the top part of this box, which again is just a tool to help me kind of get an idea that'll help me shape my asymptotes. So now I can derive my asymptotes off of this, which means that I'm going to connect the corners through the center. Likewise on the other one, because those are my lines b minus a and negative b minus a. Now I have enough information to go ahead and start to draw the hyperbola. Notice the hyperbola again has to go through those points, and these asymptotes will guard and protect the graph. And there we have a fairly good representation of what that graph looks like. The last piece of information we can probably find is where the foci are at. Foci again, what was that? Was a c squared equals an a squared plus a b squared. That's how we found foci. And so c squared we don't know, but that's 25 plus a 16 equals what, 41? So c squared equals 41, c equals root 41. And so I have some c at negative root 41, so 41 from the center. So over there, so that's some negative root 41 and 0. And the other one over here at some positive root 41 and 0. And I can put that in a black box to find out what its more approximate place on the number line is. I know it's in that rough area. So it feels fairly simple. The hard part for all of us is to keep track of the different directions that the hyperbola can go. And then might be hard to help us keep track of, is this an hyperbola or is it another conic section? Was it an ellipse? Now is 9y squared minus 4x squared equals 36 even a hyperbola? Again, that might be what's tricky, is trying to describe and try to figure out which kind of a curve this is. So let's move it to standard form and maybe we'll start to get a sense of what's going on, which means we divide everything through by 36 because we want it to equal 1. And doing that, that becomes a y squared over a 4 minus an x squared over a 9 equals 1. All right, it's a hyperbola. Now, what type of hyperbola is it? Where's the transverse axis at? Well, the transverse axis is along the y-axis because the y is positive. So this helps us understand that our a squared is the 4. So a squared equals 4, which means a equals 2. B squared equals 9. So b equals 3. And then while we're at it, we can find the c squared too, because we know c squared equals a squared plus b squared. A squared is a 4. B squared is a 9. 13, so c squared equals 13. C equals root 13. All right, so we just did a quick little track down of all the little things we know. I don't know if we're going to use them all. I just like the fact that we can do them, and if we need them later, we have them. Next part, let's go ahead and start to draw a grid axis. We know that it's along the transverse axis is the vertical y-axis, where I have an A at 2. So I probably should put some tick marks on here. I don't know if that's enough. So I have A at 2, so that means I have one point here at 0 and 2. Another point down here at 0 and negative 2. So we have those 2 points listed. Now we can start to draw our box. And our box is defined by the line of plus or minus A, which is 2. I don't know how long or why this box needs to go. And then plus or minus B, where in that case is x equals 3. All right, so there's the box that we have ready to go. That box allows me to go ahead and start to draw the asymptotes. There's our asymptotes. Given the asymptotes now that we are able to go ahead and kind of draw our hyperbola, we know our hyperbola goes through this point that we already designated and then approaches asymptotically to the asymptotes. And then we know we have foci at root 13, which is 2 squared, 3 squared, which is about a little bit past 3. So whatever root 13 is, 3 point something. Yeah, so roughly about there and about there. There's all the information that we have. We were able to find it fairly easy. Again, maybe for me, the hard part was trying to identify if it was hyperbola. I know that we're doing a hyperbolus right now, so that was my first guess. But if we were just looking at coming across an equation in random, I don't know. So the first thing I did is let's just put it in standard form and see what kind of comes from that.